when I did a practice run through of this talk, I was told to give more context, as to where I'm coming from with the talk, because it all just seemed a bit mad. So I've been programming for a long time, professionally for a long time. And then I realised after too long, really, that I preferred low-level code to high-level code. There's more fun to be had with low-level code than high-level code. Hi, Seb. And yeah, but it did take me a long time to realise that, which is a bit unfortunate. I was in a job where I was doing a lot of C#, and they suddenly gave me a bunch of tills to work on. It was really peculiar, and it was 4690 OS. Has anyone heard of 4690 OS? No? It's really bad. And they gave me pin pads to work on, and I had to encrypt some data that was travelling backwards and forwards from the pin pad to some central computer. And I just suddenly started having fun, like the sort of fun that I used to have. So, yeah, I like low-level code, and I've been doing embedded for 10 years now, which is quite a long time. We have a strong lean agile approach at the company I work for. That's capital A agile, not lowercase a agile, at Bluefruit. And so there's some context about the sort of style of working that I like. Don't let that put you off. I've also spent the last few years working on Dolphin Bat Detectors. So I took something of a sabbatical from my job at Bluefruit to go and help these guys who basically had some broken products. It's an old story that I'm sure everyone's heard. Their previous contractor had left them with a bunch of problems and no working software. And I just wanted to help, and I could see that the products were just going to go down the tube unless they got someone in. So I nearly quit my job. I still did half a day at Bluefruit just to keep my foot in the door. And I went to help with the Dolphin Bat Detectors. And that's the inspiration for this talk. So that few years of work. This is a map of all the places in the world that, it's not complete, it's not up to date. It's not a live map. It's a snapshot from a few years ago, and there are actually more places now. So this is everywhere where there are dolphin detectors running my code all over the world. And we have bat detectors now as well that also aren't represented on this map. They're not actually being sold yet. They're still being trialled by people who are really into bats, bat people. And yeah, there's a picture of a dolphin detector. It's not particularly exciting. It's got a hydrophone at one end at the top there in the picture. You can unscrew the other end, and there's an SD card slot. You can stick an SD card in it. So these are for long deployments. So it's not the sort of thing that you sling off the back of your boat and then pull in 10 minutes later. It's something that you put out in the sea for months at a time, sometimes longer. And same with the bat detectors. They're designed for long-term deployment. Here's a very poorly rendered picture of some very cold place. And I'm going to try and get some audience participation going. Don't make that leave you feeling like you need to leave. If you don't want to join in, that's fine. But yeah, I just wondered if anyone could tell me what the hardest thing about deploying to an environment like that might be. Hasn't got any power stations. That's absolutely true, and is a very tricky aspect of, there are no power stations. And what do you mean particularly, why would you need a power station for a dolphin detector? It's going to need some power, right. Yeah, so you can't run a wire to it easily. And actually, we try not to do that too much either. Oh, sorry. That's right, yeah, the internet is terrible. And you can't send that data back. And actually, it'd be quite difficult to do that with a long-term deployment. It's definitely another problem. It's not what I'm looking for. Anyone else? What was that, sir? Iceberg drift. Oh, that's a good answer. Yeah, it would be a problem for us, I think. They're probably pretty gnarly when they grind together, aren't they, icebergs? That's not what I'm looking for. Anyone else? Thank you, yeah. And particularly, what's the problem with getting there? It's because it costs Money, yeah. So this is the biggest problem with dolphin detectors and bat detectors when you want to deploy them to a remote location, and for anything really that's going to exist in a location like this on its own. Yeah, it has to have power. Maybe it needs network connectivity of some kind. But fundamentally, it just costs a hell of a lot of money to get there, thousands of pounds. The sort of money where you don't want to have to go back and check to see if it's still working the next morning. You can't easily monitor these things remotely. So there's a sort of context here. This is another very remote location. I'm pretty sure it's the Amazon. I'm not absolutely 100% sure, but it's supposed to be representative of it anyway. And yeah, it's not the sort of thing you want to keep going back to every couple of months to pick up your data. You want to go there, drop the thing off, leave it running, and then come and get it later. And these are actually the only dolphin and bat detectors in the world that let you do this. They're all mostly, they use a lot of power and record things in a raw wave format, which is kind of special because it uses loads of storage. Because you think about the frequencies involved, you can't just use a 44 kilohertz wave file anymore. You need something that can actually store dolphin clicks and bat clicks, and it's much higher frequency, in hundreds of kilohertz. So the size of the data that you need and the amount of power, whoever said that, that's it's not going to work for you. So what we actually have in these dolphin detectors and bat detectors is an FPGA. Hands up if you know what an FPGA is. Amazing. So I don't need to explain that. And what the FPGA does is it processes a bunch of stuff in real time, and then the microcontroller only draws some of that data back. It's like metadata that is deriving from it that tells it, that you're recording things about the nature of the sound that the dolphins or the bats are making, but you're not storing the entire sound on the device, just like metadata about the sound. There are a lot of bullet points. I've just seen some great presentations over the course of the last few days, and I'm not very good at making presentations, so I'm sorry. I did one on a whiteboard once here with a marker. So making long-term deployments into difficult environments is expensive. That's the biggest problem. So you need to minimize failures. Okay, it's just what I've been talking about. And I'm hoping that some of these ideas will be useful for people who don't just deploy devices into the rainforest and stuff, but just people who need things that are going to run and keep running. So I've used a metaphor, because that's what I usually do when I make a talk. And I have an explorer in the rainforest. And the explorer is a bit like our program or our system. It's the thing that's got to keep going, it's exploring the rainforest. And there's some things you need to do. You need to plan the expedition. I'm going to talk about all these in detail. You need to keep notes as you're going on your expedition. You need to sustain yourself. Whoever said about power? Absolutely. You need to handle problems that occur while you're actually in the rainforest. And you need to learn from what happened and implement changes. Okay? So I'm going to talk about all these from the perspective of code as we go through the talk, and infield updates. So if the explorer needs to learn something while he's in the rainforest, I'm going to talk about that too. So plan the expedition. This is kind of obvious, but it's still really important, so I'm saying it anyway. Your first deployment shouldn't be to the Amazon. Pretty clear, isn't it? That's not the first deployment, that's once you've refined everything. So we want to plan by doing, failing, and learning, over and over again. It's agile, okay? And that's essential. If you actually want to make something that's going to run for a long time. I would say I've learned that the hard way, but I kind of knew it before I started doing it from my other work. But it has been hard. So this is the essence of agile development. Planning too far in advance is overrated, right? So we want to do things, we want to try them out, and then we want to see what happened and adjust our behavior. So at a low level, we write tests. Yeah, at a higher level, each deployment, you need to have an idea of what constitutes a success or a failure for that deployment, that particular deployment. And then you can look at what happened in that deployment and learn from it, decide whether or not it was a success or failure, plan your next deployment, make another deployment. It's surprisingly boring, but, it's the way it is. So there are two kind of categories of deployment, and I think this is true for any deployment, really, not just my deployments. You have deployments which explore expected conditions, so things that are likely to happen in the field normally. So things like altering dates. Hands up if you've altered dates before for a program that you've written when you want to test something. Wow, nice. Yeah, got a couple. That's awesome. Because you can't get to the Arctic all times of the year, and you don't want to be recording data like all year round. Maybe you have a period of 6 months that you want to record data for, that your battery's going to last for, and you want it to start in, April, and you can only get there in September. So we have like a deep sleep mode in the Dolphin detectors and the Bat detectors where they can, it can not do anything, doesn't consume much power. The microcontroller goes to sleep, the FPGA's power is turned off, all the analog power is turned off, and basically it's, it's in a hibernation state until a certain date, so you have to alter dates. Accelerating time, anyone done that before? Show of hands. Yeah? A couple of people. Another really good technique. So we have a minute interrupt where every minute the microcontroller wakes up and then it spools all the data from the FPGA and records it to an SD card. That's fine, but you can accelerate time quite easily by just never going to sleep, or sleeping for a second instead of a minute, or sleeping for half a minute or a quarter of a minute. And you can also record data on different intervals, and there are lots of ways of accelerating time. Actually, you can change the way the FPGA works, so it records things faster. And you do introduce like different conditions that mean the test isn't quite as pure as it would be if you were putting it in the field for a long period of time, but it's really useful, and you do find problems that way. Altering space, so you can physically put the thing in a different place. We've hung bat detectors in trees, so they smash around, and dolphin detectors over the back of a wall so that it smashes against the wall, and you can physically put things in a different space. And accelerating data, anyone done that? Accelerating the rate of the data input by creating more data. I'm sure you've all know a little bit, yeah. So, for example, we did this with a bucket. Like, how many dolphins do you think there are in a bucket of water? 0? You'd hope so, but then you put a bit of sand in the bottom, stick a bubbler in there, and the sand is like, there's a sediment transport noise problem that you have to solve. So as the sand moves, it generates ultrasound, and that ultrasound looks surprisingly similar to a dolphin click. It's, it's similar enough that the FPGA can't filter it out, and we have to do that with higher level software once we get the data back. So bucket of water with sand in it. How many bats do you think there are in a CFL bulb? Compact fluorescent, yeah? So these bulbs generate ultrasound in a very similar range to bats, actually, tons of it. They're really noisy, and it's really useful if you want to just trigger extra data. You're not sure, this might not have bats in it, but it's enough to actually get the system working, and that's all you need. Anyone seen one of these before? Nice. Yeah, it's a signal generator. And they're awesome. And you can program a signal that looks very similar to a dolphin or a bat, a chirp, or whatever you like. It's a characteristic down sweep that you don't usually see. It sweeps down like that. You can get something very close with these. And we've actually got a tank in the office which, with water in it, and a signal generator and a transducer. Transducer is something that changes one form of energy to another, and it changes the electrical energy into ultrasound. So that's a really useful way of accelerating data for us anyway, but you figure out your own ways for whatever. You also have deployments which explore unexpected conditions. So these are things that you didn't know were going to happen. It's difficult, isn't it? Because how do you know? But you can exaggerate the conditions and the environments to stress test the system. And you can add flaws. So when I say that, I mean like mutation testing. Do all of you know what mutation testing is? Hands up? Yeah, pretty much. Seb knows. So you're changing things, you're deliberately breaking things, but at a more system level rather than just breaking one little bit of code. So maybe you disconnect something or break something. You deliberately leave something disconnected, or you think about the bigger picture of your system if you're not using something made out of electronics. And you're looking at extreme external situations, so physical damage, extreme temperatures. So things that you're not going to expect to happen, but if you want it to run for a year in a rainforest, what if the monkey grabs the bat detector, and starts chucking it around in the rainforest? And, you should expect the unexpected for a year deployment, yeah? Or an iceberg, I don't know who said that, but yeah, brilliant idea. Water ingress. Has anyone here tried to waterproof something before? Yeah, hands up if you're trying to waterproof something. Right, keep your hands up if that thing had electronics in it as well. Yeah, cool. And keep your hands up if you needed to allow sound to pass into that thing as well. Not so sure, yeah. Yeah, so it's a non-trivial problem. I can't state that enough. When you need to leave holes for sound to get in, and it's not like you can create like a little hood for the thing, because then the ultrasound bounces off the hood and you're going to get partial fragments of bat calls. And, it's a really difficult problem to solve. And I'm not totally convinced we have solved it. I mean, we're pretty far along the path of solving it. We have somewhere for the water to drain out of once the water gets in. And, we have the most advanced mesh thing I've ever seen in my life, that is sprayed with a special coating. And, it's still a non-trivial problem. So there's a little bit about planning. Obviously, you could plan your expedition forever and never go on it. So I'm going to talk a bit about keeping notes. This might be more controversial for some of you, but interesting to know. So the bold explorer needs to keep a diary of what happened, because if you die, you die. But at least you've left something behind, something retrievable, something you can learn from later. I think there are many programs that struggle with this. Anyone know who that is? It is, yeah, he got all the answers. We should chat. It's Chris McCandles. I don't know if that's how you say his name. And it's a true story into the wild about this guy who went off and tried to survive. Yeah, it's terrible, really sad story. Was it Siberia or something? I think Alaska, yeah. Yeah. Yeah, it's a tragic story. And the only reason we know anything about it is because he kept notes in the bus. He wrote down a journal of everything that he was doing. And, I think he scratched it onto something, It's mad. So your device or system needs to keep a log of what's happened. And that log needs to be accessible at some time, not buried somewhere on the device. So I think almost everything I've ever used is crap at this. It's just like, almost everything, where does it go, I'm going to talk more about that. Errors need to be translated into plain English. So not some perverse error code that doesn't make any sense. And you're just like, okay, I've got this horrible error and I have no idea what it means. And you have to go and figure out what it means. Maybe you can't Google it, it's ridiculous. So sometimes if you haven't got enough memory, you need to use a partner program to translate the errors or something like that. I'm going to talk more about error handling, but I'm going to talk about it more in a minute. So sustenance, so we've already touched on this a little bit. Anything external your system needs to run. Okay, it's not food and water for a computer system, but for a computer-based system, it's power and network bandwidth, potentially. It's what you need to run. So you're going into the jungle. everyone imagining it. How do you package the food? Anyone, any ideas? Yeah, tightly, that's good, yeah. Resealable, cool. Anyone else? Sorry, anything else? No? Do you put it all into one big container? And then, no? No. And you don't do that because if it spoils, if you get a bit of mold in the container or a bit of water or something like that, you haven't got any food left. So a universal power supply is pretty useless in the rainforest, as a couple of people already touched on. Solar panels are not useless, so solar panels are useful. Do any of you actually do embedded programming? You put your hands up if you make products with device. Yeah, cool, okay. Not totally useless, this bit then. Individual battery cells can still cause problems. So I don't think it's good to rely on a single power source if you're deploying something to a hazardous environment. I think if you care about it running for a long time, you need to be able to switch if something goes wrong with that power source. It's better to have several stacks of batteries that are individually selectable. Batteries, I don't know who here might know about physics, they're very strange things. They can perform somersaults when you're not expecting them to, literally. And one bad cell in a battery will screw you. So, yeah, it's really important to have actually multiple power sources that you can monitor. So that when they're low, you can combine them all together, which might give you a better chance of surviving. And they need to be monitored for future review. So you need to know when you get the device back from the jungle or from your shorter expedition that, where you're preparing still to go into the jungle. You need to have a look at the stacks and see how they depleted over time. And you need to be really on that if you want something that's going to survive. So it's important to load test for the embedded people here that are interested. You place an electrical load on the battery rather than just looking at the voltage once or twice or three times. It doesn't matter because a battery with a bad cell can collapse under load, so it's really important. And if you can get a Coulomb counter in there, I think someone in a talk was talking about Coulomb counters. They described it slightly different. One of the lightning talks, they mentioned a chirp, a pulse. They were monitoring from their central heating system or something. Sounded like a Coulomb counter. And that gives you a much more accurate idea of what's going on. So you're running low on power or anything, food or water. Do you give up or carry on? Depends. Yeah. I don't think you can give up. If you're running out of food, you're running out of water, you're probably not just going to wait there, are you? You need to what are you going to do? It's an endurance race. Ration. Nice. Yeah, lovely. You need to ration your food and water, but you need to keep going because you need to find more food and water. Or maybe your targets are slightly different. Maybe you need to run for a year in the damn rainforest. So you might want to slow down a little bit. Maybe don't do some of the things that you were doing. So you bring your sort of consumption levels right down so that you're not making the problem worse as far as you can. Writing to file systems when you're low on power is a bit fun. It can cause problems as well. So maybe it's best not to do that. And it puts quite a lot of load on the batteries. So you need to think about the load that everything is putting on batteries. Consider all your activities. And this applies for network connectivity as well. If you're finding that you don't have enough to do what you want to do, maybe drop it back a little bit and wait a little bit before you carry on, rather than just giving up. And maybe you just don't want to be doing anything except regularly checking your power. So you're just, looking for food, like trying to cite food, just sort of analogous to that. So, and if you've got a solar panel, even better. It's particularly true when you get momentary interruptions of power. So If you're throwing a device around, then you're likely to get interruptions of power, which is, a big problem. Capacitors are useful for that. So you can stick some massive capacitors on a board. They're basically batteries, and that can help smooth over power interrupts. So that's useful if you're doing embedded stuff. It's worth considering if you're worried about things continuing to run. Right, I'm getting to the biggest chunk of the talk now, which is handling problems. Everyone know what that is? It's a brick. Why have I got a picture of a brick on the board? That's right. Yeah, so you don't really want to deploy a brick into the rainforest, or something that becomes a brick, and then you're spending a lot of money and conservation effort taking a brick out and bringing it back. And there were deployments. There have been deployments in the past in live systems with this system where they've gone and got the SD card and put it in, and they've gone out in their boat and they've stuck the pod down under the water, and they've gone back to get it a couple of months later, and it didn't even start recording. So that's, you don't really want that to happen. You've delivered a brick to the depths of the ocean to watch it do nothing. So the way we avoid bricking a system is to handle problems. There are always going to be problems. So what you need to do is handle them gracefully if you care about the system running forever. So the explorer is encountering a problem. He's got lost. His compass isn't working. He's got his map. He's confused. He's in the Amazon. He has a few options, okay? So he's realised that he doesn't know where he is and his compass isn't working. Should he ignore the problem? Just carry on. Sit and wait for help. Go back to the start of the last little path that made sense. Maybe he can do that if he can backtrack a little bit. Make a note of what happened and try again. Or start the whole journey from scratch. That's a tricky one to achieve. Or you could make a note of what happened and try and keep going. So, show of hands for number one. Do you think he should just ignore the problem? Yeah, absolutely. Well, I told you what the problem is. His compass is broken. He's lost. He's got a map. Come on, Seb. Turn down the heckling. This is the context. What should he do? What would you do? Not be in the Amazon with a broken compass. That's a cool idea. Yeah, that's an awesome idea. So you're trying to find a workaround. Yeah, that's a good idea. It's not one of the options, though. Yeah, number three. Yeah, number three is a good choice. I like number three. Anyone else number three? He's only going back to the start of the last little path that made sense, so he can backtrack. He's like, I've just been there. I'm going to go back over there and see if I can find my bearings. Well, if he's just walking around like this, if he's like taking in his surroundings and like making notes and stuff, then he might know where he is. Any other suggestions? I like the sun one. So here's a bit of live code. In my work at Bluefruit, I often get code to review, which is exciting, because we want to see, how easy it's going to be to work with someone, and it strongly affects whether or not we suggest rewriting the code or using their code. And this was the error handler that I found in the code. It's classy. And this is option one, right? Ignore the problem. And this is what they did in that code base. They just ignored the problem. They didn't seem to care when I told them about it either. They were like, oh yeah, we know we've got to fix a few things. I was like, oh my God. Okay, yeah. So I have a couple of, this code, by the way, is in lots of code bases because it's part of the code that ST sort of give people to use on embedded systems, and everyone just sucks it up because they don't want to write their own code, and here it is. So I have a couple of things to talk about that. So this is this function block at the top. This function is executed in case of error occurrence. It's an error handler. I mean, I could have worked that out. And also this, like, come on, like, this is unbelievable, isn't it? Like, what are they going to do? Search everywhere where it says user code begin? Like, no, it's not going to happen. So this is, I hate this code. Hate it. So option 2, sit where you are and wait. So this is another code base. And it wasn't much better than the one that we just looked at. But it's the same error handler because obviously it's ST code, so they give you the thing. But these guys are, oh, hang on a minute, it's the error handler. We have to do something here because, handle the error somehow. There are lots of things wrong with this. Yeah. So, I mean, it's not even... yeah, why is that? Yeah, so Seb hates this one more because it's looping infinitely. That there is a side effect to that we'll talk about in a minute, but yeah, it's... Sorry? I'm sorry. Yeah. I mean, it's just... yeah, it's absolutely terrible. It's not even spitting the error out on the serial port, or it's making absolutely no effort to inform anyone about anything that's happened.
Still got a comment that the user can add.
Yeah, they left that in, yeah.
And it's his.
Yeah. No, it's beautiful, isn't it? Yeah. Well, yeah, not in the rainforest, you can't. But yeah, it'd be a long cable and it wouldn't work, the voltage drop. Yeah, you're right, yeah. At least it exists. It's not just going to get optimized away and you can't even hit a breakpoint in there. Yeah. Ooh, yeah. I mean, it's almost worse than, it's almost worse than just ignoring a return value, this one. Yeah, it's, yeah. So I'm going to talk a little bit about assert and its embedded bedfellow, capitals assert, because lowercase assert doesn't really exist in the embedded world. They're very useful when you're busy programming. I remember there was some advice, you should have so many asserts per n line of code. I can't remember, 3 asserts per, I don't know. I can't remember the exact advice, but it's reasonable advice. Asserts are very useful, but they're pretty bad when you're not busy programming, so in a live system. It's very important to make sure that assertions are disabled in production code that needs to keep running, unless you are extremely confident about what happens next. I deliberately moved closer to the mic. Is that a good effect? So what happens next is like the main thing, the main part of my talk, really, because it's just not thought about. When you're error handling, your program tapping away, I'm getting loads of work done, features working. Yeah, I'm going to handle that error code. Yeah, you're handling that error code. Spit it into a log somewhere. Blah, blah, blah. Yeah, but what's happening to that error? Who's looking at that error? And with assert, you need to be really sure. I'll talk about that in a bit. I'll talk about that more in a second. So what happens next? It's a useful thought experiment when you're designing error handling functionality. And I think if you take one thing away from all this nonsense that I'm spewing here, what happens next should be the 3 words that you sort of bring into your consciousness while you're writing code. Is our explorer clearly not thinking about what happens next? Okay. So what about undefined behavior? I can't hear any of you crying about that, but there's this argument that I've seen in code reviews, and people using asserts like to make the claim that if you keep running when you have a sort of a state of the system that you're uncertain about, so your pointer's null, and it shouldn't be null, and you're going to get a null dereference or some nonsense. So you assert that then that's a reasonable place to assert. And maybe that's something that you really do need to handle. Like there's a hard error there, but yeah, you've really got to think about what happens next when you assert. In an embedded device, maybe you have a capital letters assert, and that's a while one loop. So static assert. Everyone here using static assert by now? Yeah, hands up if you use static assert. Nice. It's compile time. It's a much better solution than assert. So obviously you can't static assert everything, it's only on const expressions, but if you can static assert about something instead of asserting about something, that's great, and it's better, so try and do that. I haven't quite finished talking about assert yet, but I'm sidestepping into standard strings. So we have this string here, and I'd like to ask you all what significant thing happens when I add "I smell the blood of an Englishman" to fee, fi, fo, fum. Beg pardon? Thank you very much. Embedded programmer? No? Performance programmer, cool. Yeah, that's good. So yeah, I mean, fee, fi, fo, fum. I mean, it's not always 16 bytes, but every one that I've checked, the implementation's been 16 bytes of the string are stored on the stack. And as soon as you go over 16 bytes, it allocates the whole thing onto the heap instead. So that's interesting. Interview question. Does that trigger anyone? Yeah? Interview question. What happens when operator new fails? It's a really common interview question. Anyone know? Well, maybe not you, don't answer. Hands up if you know what happens when operator new fails. Thank you. Go on. An exception, yeah. And bad alloc, isn't it? Cool. Is that true on embedded? Anyone who does embedded? It depends, yeah. That's important. Yeah, that's important. So going back to option 3 of our handle problems, which was go back a bit and see if you can find your path there. I really like option 3, but it does have some problems. Exceptions, that's what I was getting at. They're much harder to use in embedded environments. There's a bunch of reasons they're disabled by default. They use a lot of memory. They expect you to have a fully featured standard library. How am I doing for time? Does anyone know? Am I winning? Okay, it's not too bad. They expect you to use a fully featured standard library, so, you know, that's a problem. They're kind of slow. That's pretty important. And what happens next? What happens next? So if the exception and catch don't modify anything before retrying, is it ever going to work? No, thank you. That's not going to work, yeah. So the bad alloc exception, yeah, catch it somewhere higher up. You get back down to the same point again. You'd be lucky, wouldn't you, if it worked after it failed before. It's just going to do the same thing again. So we're going to talk about option 4 again, start the journey over, which is difficult for our explorer. And I'm going to talk about 4690 store systems again, just briefly. So it was my second job when I was working on these things. I was in my early 20s, and it was hell. I got to this program that was running on one of these, the back ends of these store systems. And it was responsible for processing a bunch of loyalty card data. So, you know, really boring. And the guy who handed it over to me to look at a problem with it, first of all, he said to me, don't use the debugger. You can't use the debugger for this. Just do printfs. Like, that's how I debug it. That's the only way you're going to debug it. And I was like, screw this guy, you know. I want to use the debugger. And I spent a good couple of days trying to get the debugger working, and I couldn't get it to work with the tools. You know, the tool chain was completely screwed. Am I allowed to swear? I do tend to swear a little bit. Hands up if you mind me swearing. Okay, good. Oh, there are people live. Oh, yeah, it's because I'm talking about this. I'm expecting I'm going to start swearing. Yeah, so I couldn't use the debugger. It was just printfs. And, you know, eventually I accepted this. And I was like, meekly just went back to my printfs to figure out what the fuck was going on, because I couldn't figure it out. And I did eventually sort of start to figure out what was going on, and it was leaking memory. But it was leaking memory in sort of all kinds of horrendous ways, and I would have had to just rewrite the whole thing to figure out exactly what was, I had no debugging tools, couldn't val grind, or there's nothing there, it's just printf, So what someone clever had done was write a little background process. I think they called them in 4690, which just monitored whether or not this really important process that was running had stopped. And if it had stopped, it started it again. Beautiful. But it worked. So it ran out of memory regularly, and then it would die, and then the restarter would restart it, and it would start again. It was basically turning it off and on again, a bit like my Wi-Fi connection just now. It was terrible. I really hated working on that. But I'm just going to ask you what happens next in this example again. So Seb didn't like it because it was a while one loop that ran forever and just span. Anyone know better what might happen next? Yeah, go on. Watchdog, thank you very much. The watchdog, okay? So if you happen, and actually I'm pretty sure there wasn't a watchdog running in this particular system, but if there had been a watchdog running, then it would reset it. That can be a desirable thing. I'm going to talk a little bit about watchdogs. So I'm going to talk about software and hardware watchdogs. Hands up if you know what a software watchdog is. Okay, good. I'm going to kind of explain it. So hardware watchdogs are awesome if you're writing embedded code, but they're kind of crude. They're really crude, actually. So for anyone who's not sure about what a watchdog is, I'll just explain it very briefly. It's this little module, a little peripheral in the microcontroller, so that's sort of separate from everything else, and it's just monitoring, whether or not it's been kicked recently. So the rest of the microcontroller is responsible for, they call it kicking. It's nicer to call it feeding the dog than kicking the dog. But yeah, regularly you have to kick the dog, otherwise it resets the microcontroller. So the watchdog internally has control of the reset line, and it will reset your microcontroller for you if it doesn't get fed in time. So that's really useful, really powerful. But it's kind of crude, and it's crude because, where do you feed the dog? Where do you kick the dog? You don't just want to kick the dog randomly everywhere, because then it's not going to do anything. Except in the case of that while one loop, although, you do find things like that where they're kicking the dog repeatedly in the while one loop just to stop it from resetting the microcontroller as well. But yeah, it's true. It's kind of crude, yeah? So in Linux or other high-level OSs, you have a kernel watchdog, which is there for you, and it has its place. But software-level watchdogs are really powerful, and they can be used in embedded and high-level systems. So software watchdog is something that you can use anywhere. You can have a check-in for each thread or module in your system. So you can, your software watchdog is waiting, for check-ins and things, and you probably have some kind of call to that watchdog regularly that processes whether or not it's had all the check-ins that it needs. You'd need something like that. And you can customize it, and you can configure the check-in frequency for each thread in your system. So if you expect a particular thread to check in with you once an hour and another one to check in with you every 5 minutes, that's really useful. That's useful in embedded and everything else. Software watchdogs are really cool. You can entirely customize ways of handling the failure to check in. So, maybe you don't want to just restart the whole program. Maybe that's not the best thing to do. Maybe you just want to restart a thread, or maybe you just want to say, oh, what's going on with that thing there? Has it had an error? You can make these software watchdogs as clever as you want. And it's worth it sometimes. You can combine it with a hardware watchdog, or a kernel watchdog. So you could trigger a reset if you wanted to, using the software watchdog. So combinationally, the software watchdog and the kernel or hardware watchdog, it's super powerful, and it's worth having them in your system. So I'm going to talk about learning from what happened and implementing changes. So this is where I refer back to keeping notes, and we get some more detail on that. So here's our explorer. He's come back from his expedition. And obviously you want multiple deployments, not a single one. But this is where your error log becomes really important. But it's no good buried away in error log. If you know what error log is in Linux, you've got this error log, and all the errors go there, but no one ever looks at it. Yeah? Big problem. Or the event viewer, the event log in Windows. Yeah? It's really normal for programs to log errors to the event log. And users don't even know what it is. Like my mum, for example, she was a programmer for 20 years, whatever, Model 204. I'm sure no one here knows what that is. Mainframe programming, stuff like that. I'm frequently explaining to her what the bloody event viewer is. I don't even use Windows, but I have to. I'm like constantly, Mum, you've got to go to the event viewer and look to see if you've got any errors in your event log, because the thing's not working, but it could be logging things to the event log. It doesn't tell you. The programs don't flash up usually, or they do, and it's some fatal error or something, and you don't. All the detail is kind of hidden away. So that's rubbish. It needs to be reviewed carefully by someone or something. So it's important to expose errors in the most meaningful way possible at the highest level you can. So if you have a system that needs to run for a long time, or even if you care about errors, you need to expose those errors in your system at the highest level you can. So you need to think about how much memory you can spare for your error log. I'm sure most people here don't even think about memory most of the time. Oh, maybe you do if you care about performance. But how much memory can you spare? A couple of dozen bytes, on a small system might need extra software to turn those errors into something meaningful. If you have more memory, I think it's good to store things in plain language. And that's something I don't see very often. But the plainer the language, the better. And multi-language error recording, that's pretty powerful. If you can do it, and if you've got users all over the world and they can't read English, it's worth considering. But there are some problems with that. So, it's that problem of indirection again. You create IDs and tags for things and that are translated into errors. But, the programmer comes along, and I'm sure some of you have worked in a system where you have to log an error, but it's not that simple. It's not just a text string or something. You have to add the error to some kind of log thing, and then you get the ID that you want to use, and you put that in there, and then there's another system that needs to be updated to read that, and sometimes you end up with an error that doesn't have any description because the token hasn't been, it's just, there's a whole nest of problems there with using tags instead of plain language. So it's just something I've come across that I want to talk about. So I'm going to give you a brief history of error reporting on the bat and dolphin detectors, because it's kind of entertaining, and you might enjoy it. It might be useful. So when I first joined the project, there were 3 ways that errors were handled. There was a while one, and there were while ones everywhere. Not just one in that beautiful error handler. Didn't just call the error handler when there was an error. They were everywhere. They were in the file system. They were everywhere, while ones. And one of the first things I did, the first problem I had to solve was the stopping problem. The stopping problem turns out, it's quite a big problem, actually. It could be anything that's stopping it. I don't know what's stopping it. Or nothing. So that was quite common. If there was an error, wasn't even picked up, wasn't detected, wasn't logged, nothing. Or you get a 0x03. And that was there was 1 byte for errors in the EEPROM, which is sometimes called an E-squared PROM. It's a little bit of memory inside the microcontroller where you can store things. So it would get a 0x03 when it ran out of batteries. It would just get stored in the E squared. So if anyone, for the people who do embedded, or you know this, but for other people, it's quite hard to get errors out of the E squared. It's inside the microcontroller. You actually have to get the board, connect a programming cable, and read the memory off the microcontroller, and then find the position in the bloody hex, and then check to see if it's 0x03. And there was a chap working on these projects. I'm not going to mention his name. He was doing this like over and over and over again because the thing kept stopping. And so they'd have to give him the board, and then he'd get the board and he'd plug it in, and he's going, oh yeah, it's a 0x03. Oh, there's no 0x03, so it looks like the batteries were okay. Don't know what happened. Yeah, not sure. And then he'd rearrange chunks of code. This is one of the things he was doing, rearranging chunks of code and then rebuilding it and redeploying it. Yeah, no, seriously. Oh yeah, I think this will be better. This will be better. And they deploy these things for like months again, or weeks, months, and then they come back. They'd have stopped, stopping problems. So one of the first things I did when I got in there was introduced a type called subsystem and defined these different subsystems. So these are parts of the system. There's a configuration aspect of the system, I2C, this is just communication protocol, SPI as well, ADC, E squared, RTC, that's real-time clock, file system, power. These are all things that were going wrong, but they just had while ones or they weren't handled. Yeah, that was fun. And I changed it to store 3 errors instead of 1, which I didn't think was too ambitious, and dump them to a serial port so I could actually see what was going on. And I could have gone further at that point, but I didn't feel like it. And what I did is I made another system that was just a tiny little STM32 micro, wee little board like that, and I stuck an RGB LED on it, and I made it light up a different color depending on what the reason for it stopping was. So I was really broad brush with it, because it was just such a nightmare. You can't just go in and fix all those problems. Like, they had a stopping problem, I need to figure out why it was stopping. And this was a colourful way of finding out. I didn't have to connect a programming cable to see whether or not it had run out of batteries. Suddenly I had a power thing, and I'd use the other colours, it's a really quick way of differentiating what had happened. Then I added report files, which, sounds like a pretty simple thing. It's an SD card, you stick it into the Dolphin detector. It writes a file that you can get off the SD card, so the users can actually see the errors. Now, I realise you're probably not using SD cards for your output, but maybe you could figure some way of showing the users your errors if you're not. It's just an idea. This was the first iteration of a report file on the Dolphin Bat Detectors. Isn't it beautiful? If you have a problem, you can send it to an email address. You've got the date time that the thing reset. That was useful, because obviously if you don't set the clock, then that's going to be wrong, and that can affect other things. And the unit number, the release version of the software, the FPGA version, the hardware version, how many errors occurred, and the last 3 errors. I did make the mistake, first of all, of not translating the errors, which I quickly rectified, so I could see what the actual errors were. This is a temperature sensor error. It timed out converting the temperature, which is interesting, and that turned out to be a hardware problem. And yeah, this is how you do it. And this is the latest iteration. Is it the latest one? It's not quite the latest one. I think I've got one more. Yeah, it's the penultimate iteration of the report file. So, funny thing about errors on embedded when you've got power problems and other things going wrong is that it's quite easy to stick something in the EEPROM, but it's kind of harder to write to a file. So when you write to a file, as I mentioned before with the Explorer, You kind of need to dial things back when you've got problems, and writing to a file is quite an intense thing. It draws a lot of power. It takes a lot of processing. Relatively speaking, it's a heavyweight thing. So the startup report actually reports the previous run's errors in this example. So we added a shutdown report as well, which is a really cool idea. It wasn't my idea. And the shutdown report happens when you take the thing out and you press the button. So that's useful because you know whether or not it's writing to the file when it shuts down, and you get a summary of any errors that were found. And yeah, it's a really useful thing. And the shutdown report refers to the current run rather than the previous run. Obviously, you wouldn't do that if you didn't have enough power, you'd had other problems. But yeah, now you have this startup report and a shutdown report. So that was cool. And then my most recent improvement to this was to add the data file name. So the data file name is the name of the file that the particular log relates to. Embarrassed by how long it took me to realise I needed to add that. But I was starting to get lots of reports from the field. This person, I'd get sent data files and report files, and I didn't know if the report file definitely related to the data file, or if they were just making it up, or they'd sent me the wrong file, and I'd get all kinds of files, and sometimes they'd change them, and bless them. A lot of these people were marine biologists. They're not ill-suited to the sort of workflow that we have when we're sort of careful about file. And even then, I'd make mistakes, not necessarily looking at the right file. So that was really useful. Another thing I did, which I haven't got a slide on, is I started adding inline error reporting into the data file itself, which I couldn't do for everything, but it was pretty useful. It's still quite useful. So now when the users open the data on their higher level program, which actually does a lot more work looking for the dolphin calls, like the intelligent bit, if you like, looking at the data that the FPGA has already filtered. I've just lost my thread totally. What happens is a little box appears at the bottom and it prints out the errors that happened in plain English for the users to see, which I know some people think it's good to hide these things from the users, but I don't think it's good to hide them. Especially if they care about their data and they're interested in what happened, and you want feedback from them. So, gosh, it's 5 o'clock. Okay. I've still got a little bit to talk about. So I'm going to talk about infield updates now. This is a bit of a gnarly topic, but yeah. So you fixed a problem you've encountered in another expedition. You want to let your explorer friend know about it. I'm trying to make this light. So let's talk about bootloaders and firmware over-the-air design. Referring us back to this brick, because this is a really common problem with bootloaders and firmware over-the-air. Firmware over-the-air just means you're sending the device a new software update remotely over, radio or whatever. So the first rule of any system capable of being updated in the field is not to create a brick. It's a simple statement, but it hides a lot of detail, so I'm going to talk about that a little bit. So for those who don't know, a bootloader is a relatively small chunk of code which is executed either immediately in embedded systems or it's loaded by the BIOS. Often sits in the master boot record or at the start or end of code flash in an embedded system. I've made a bunch of bootloaders now, and I'm just going to give you some tips for any of you that end up making bootloaders. My first tip is don't use the ST bootloader. And I refer you back to the error handler if you're not sure why. I know it's more interesting for people who work on embedded systems, but you never know, you might figure out that you like them too. So keep it as simple as possible. That's not simple enough. Yeah, so a bootloader is as simple as it can be if you want it to reliably work. The very simplest bootloader just checks a flag. And it either jumps into the binary that it already has loaded in code flash if it doesn't need to load a new one, or it loads a new binary from external flash into the code flash. Did I mention files? Nope. Did I mention USB? No. There are many bootloaders out there with USB stacks inside the bootloader, which just strikes me as completely nuts. Like, why would you do that? Why would you have a stack in a bootloader? I have no idea. Well, I do know why they do it. They do it so that you can plug in a USB stick and more easily bootload a new system. But it's a horrendous shortcut. Yeah, if you copy that binary into code into external flash and then load it from external flash, you don't need a USB stack in your bootloader. So it's crazy. Did I mention Ethernet? No. Yeah, so has anyone here come across Pixie booting before? PXE? Oh, man. It is the biggest load of... Yeah. So I spent some time debugging a Pixie boot on some of these old systems. And, yeah, I mean, it's just a complete nightmare. And it's a nightmare to debug. And it's just not sensible having Ethernet capability in your bootloader if you want it to always work. You might also want a third binary available, like a factory image or something, which you can reset to via the hardware. That is if your hardware is not in a rainforest, because you can't press a button. But maybe you could have a third image that your system, when it realizes that it's in a bad enough state to warrant it, it can switch to its, factory image. It's like, hang on a minute, I keep crashing, I keep having a bad alloc exception, or, I mean, whether or not you should use the heap at all embedded is a long question as well. But yeah, factory image could solve that, especially if you allow your program to use it. So if you decide to have a third binary, you need to make sure that its inputs and outputs are consistent across the lifetime of the device. So at minimum, you need to be able to update from your factory image to the latest version. That's a kind of non-trivial point to make. It's pointless having a factory image to avoid creating a brick if you then create a brick when you revert to it. Is that obvious? I'm not sure. Apparently not, because a lot of factory images can't be updated because the updating strategy it doesn't support them anymore because it's been updated. So what's the ideal version number of a bootloader? Having listened to that, any ideas? No? It's a bit of a silly question. I mean, it's kind of one, right? You never want to have to update the bootloader. If you're updating your bootloader, well, for a start, you can't do it in the field. You'd have to do it on the device. But additionally, you start to get trust. You start to build trust in things the longer you use them. And that is especially true of bootloaders. So if you've got your bootloader that you've been using for 4 years and it's never failed you, and all it's doing is transferring a firmware image from external flash onto your microcontroller, maybe it will fail. Maybe one day you create a new image, a new firmware image, which is a little bit too big, or it's different in some way that causes it to fail. It's got a funny character that messes with it or something. But it's kind of unlikely. If it's worked all that time, and it's likely to keep working. So it's a slightly silly question. But when you're dealing with hardware, you do need to be prepared. So you should assume that you will need to revise the bootloader at some point. And this is something that a lot of people don't pay attention to, especially these days with chips being hard to find. So this is an increasing problem. Has it affected anyone? Hands up if the chip shortage has affected you in any way. Oh, yeah. Yeah, I mean, it's kind of terrible, really. So we're up to version 3 in our bootloader, the Dolphin Bat Detector bootloader, which I wrote. And that's because we've had 2 additional flash chips that we've had to support. And that's my only dependency, because otherwise, unless we change the microcontroller, the bootloader's not going to change in all probability. But those 2 additional flash chips, that is something you need to bear in mind, that you might need to do that. So you need to keep building and testing your bootloaders, even if you're not working on them or using them. So ideally, you want to keep using version 1 of the bootloader forever. But you need to keep building the bloody bootloader, because if your flash chip becomes unavailable, you need to get a new flash chip. You need to update the bootloader to support that flash chip. And if you haven't been building your bootloader, maybe it doesn't build anymore because you're using a newer version of the compiler or something. And so it's really important to keep building and testing bootloaders. Okay, that's bootloaders covered, right? I'm going to talk about firmware over the air strategy. So it's probably a bit more relevant for you. We're getting somewhere with the bootloader. When you're planning an update, it's a good idea to test it against the oldest and newest versions of your software. So can you update from your oldest version of software? And can you update from your newest version or penultimate version of software? And by this I mean, do these versions update to the new version adequately? So not only can you update, do they still work afterwards? Is it a good update? Make sure you can update the oldest to the latest, and consider testing it against all versions that are in the field. So if you don't have many that are out there, test it against all of them. If your new firmware update, especially if you're pushing it out over the air. So if you're not doing this locally with an SD card or some other way, maybe if it's a full-blown application, maybe you're actually there. But if you're not actually there, then you really need to be testing it against lots of different versions. It's really important. So remember, it's firmware over the air, not bricking over the air. So we don't want to create a brick with our transfer. Really important. Talk a little bit more about firmware over the air strategy. Our explorer's busy watching for messages. He's only got birds to get him messages in the jungle, unfortunately. But he's not paying attention to the snake. That's a big problem, right? And this is a big problem. It's important to consider what impact the process of updating has on your system. So if it's going to occupy your system to an extent that it jeopardizes its chances of success, that's a big problem. It's a problem that I've seen repeatedly. It's a problem that you need to account for. So depending on what frequency you use to achieve an over-the-air update, you could encounter legal limits on the length of radio transmission periods. So if you've got a system that, there are a few of them, and they're talking to each other, and then you have a firmware over-the-air update comes in, suddenly you could stop all your devices from being legally allowed to talk to each other for a period of time. You can kind of get around that a little bit with like trickling and stuff like that. So if you trickle the firmware update over a lower rate than it's capable of being received at, that's a useful thing to do. That's important. You can get around it a bit with AFA, which is adaptive frequency agility or frequency hopping. So, if you've got a 1% transmission limit on an 868 megahertz frequency, but you switch to another frequency and switch back, switch to another frequency, you can, you're using a different carrier frequency, so it doesn't blow the 1% limit. It's useful. So it's just some advice if you're trying to do firmware over the air and, locally, a bit more locally. So there's a little summary of what we've talked about so far. There is some more after this. Not too much, though. So for appropriate error handling, you always need to consider what happens next at every level. So what does the program do next? What does the system do next? What does the user do next? What does the programmer do next? So, if you're not getting your errors fed back to the programmer, something's going wrong. One of the first systems I worked on, I made something so it sent me a text when it went wrong. And it's a really simple thing, but it was amazing because I get texts all kinds of weird times, giving me error reports. But without that, I probably would have never seen the error. And the users probably wouldn't have complained about it because when they tried it again, it kind of worked. And, that's not realistic for most systems that you work on to get a text every time there's an error. But, it's a useful thought experiment, isn't it? How do you get that message back to the programmer to let them know that there's a problem with the system? And, maybe they don't care about it. Maybe someone higher up, decides that, they don't want to waste money fixing the problem. That's possible too. But, still to make that decision, you need to see the error. So these feedback loops are critical to building something that will run forever. So if you really do want to make something that's going to run and run and run, you need to expose these errors and get them fed back to you. Assert is dangerous if you don't disable it in your production code. Yeah, it's just to take it out. You can do that in production only, and have your developer build not still assert, and then the asserts are useful in there. But basically, yeah, you need to disable it. Throwing exceptions is awesome if your program isn't just going to run around lost. So going back to the Explorer example, it's really good to get your bearings, go back a little bit and unwind the stack. It's fantastic. But if you're just going to do the same thing again and you're not going to modify your behavior, then, or you're just, in a chaotic cycle, maybe you need to restart the actual whole thing. Maybe you need to do something different. Bootloaders should be simple to reduce the risk of failure. So, watchdogs are powerful aids, but you must consider what happens next. What happens next when the program, system, or hardware resets? That's really important. So, you chuck a watchdog in there because someone says that they need a watchdog. That's not conscientious programming, is it? That's paying lip service to the thing. Yeah, I've put a watchdog in there, but it's just going to do the same thing every time it resets. That's not that useful. Firmware over the air should never be bricking over the air, and it's up to you to make sure that's not true by testing your different updates against different versions. So I have an addendum. How much time have I got left? 15 minutes, not bad. Which is about software quality. So I mentioned this. I drew that by hand, can you tell? It's do, learn, and adjust, right? This is the feedback, the fundamental feedback loop that I started talking about. Is very similar to this. Failing test, passing test, refactor. Not accidentally. And that's very similar to this. Having a failed deployment, learning from it, and then having a successful deployment. And you need to do lots and lots and lots and lots and lots of that. It's very similar to this. Hypothesis, an experiment, and learning from that experiment. So this is why you need to feedback your errors, because otherwise you're never going to learn anything from your experiments, But you need to log the errors for a start, But yeah, I have actually heard people say, people making embedded software in companies that, we can't do anything about the errors anyway because it's in a device. So, we're just not going to handle the error. It's like, takes a bit of experiencing the pain of trying to get something to work to understand like how nonsense that is. And it's really nonsense. And yeah, and you don't have to, maybe you can't actually use an SD card, but you don't have to rely on a programming cable to get the errors out of an embedded system. There are other ways, it's like, yeah. So the Dolphin detectors and bat detectors I've been working on, every time I make a release, I make a tag, and it's a really easy way for me to check how many releases I've made. It's 172 releases in 4 years, which I'm kind of proud of, actually, which sounds like, oh, why didn't you get it right the first time? But you're not going to get it right the first time, and this is kind of about right, I think. It's 43 a year, 3 a month. And I'm still making releases. They're a lot less frequent now. I'm doing more work for Bluefruit again. And the system is pretty much done. But, we're still making improvements, still making releases. So I'm still counting with that. And here's a lovely picture of a bat. Because I haven't really talked about, what the dolphin detectors and the bat detectors are actually for. So I just wanted to, as an aside, mention that 40% of the world's bat species are currently endangered, and it's kind of getting worse. They struggle with human development, and yeah, they're still struggling. And a picture of some dolphins. I'm going to talk a little bit more about the dolphins, actually. Dolphins are endangered by lots of human activities, and the purpose of these bat detectors and dolphin detectors is to kind of try and monitor them and see whether the population's declining or increasing. And does anyone know how you do that? It's a trick question. It's impossible. Is an unsolved problem. So if you know any maths geniuses who are itching to get their teeth into something, trying to determine the population size of a group of underwater mammals is 100% an unsolved problem. If you imagine what the data looks like, I should have given you a slide of that, but you get all these down sweeps that you can visualize and you can look at it all, but how do you know one down sweep is one dolphin and not, you've got 10 down sweeps. One down sweep probably is one dolphin, but if you've got 10 down sweeps, then that could be one dolphin 10 times, or two dolphins 5 times, or any combination of that. Or it could be a whole bunch of dolphins, and some of them are being quiet, and some of them are being noisy, and so it's a problem that Chelonia are trying to solve, and it's a very difficult statistical problem, actually, which is way out of my comfort zone. So yeah, that's what the dolphin detectors are for, though, because even if you can't tell exactly how many dolphins or bats there are present, you can tell whether you're getting more data over time or less data over time. So you can work out a trend, and that's what they're doing. Seeing whether or not they're trending, and also whether or not they're present. So if someone wants to build something in the ocean, then shouldn't really do it if there are loads of dolphins there. So yeah, governments are sort of getting wise to this over time. Does anyone know why dolphins are endangered? This is where I go on a bit of a rant. It's nothing to do with the talk. Anyone? Fishing. Is that what you said? Trawler fishing. Who was that? Who said that? Nice. Yeah. Basically, that's why. And there's also noise, so you get noisy environments in the water, which they don't like. But nets that catch fish, they also catch dolphins and porpoises. Okay? I'm not trying to guilt trip any of you if you eat fish. I am trying to guilt trip any of you if you eat fish. But yeah, 100%. They all catch dolphins and porpoises. One of the first things this company did when they started looking into making these dolphin detectors, and it was a little bit before that, was they put people on boats, monitors on boats. They had to persuade the fishermen to do this, which you can imagine wasn't easy, but they did somehow convince fishermen to have people monitor on the boats, like how often they were catching dolphins and porpoises, because the fishermen just lie about it. Of course they would, wouldn't they? I don't want to crush anyone's romantic view of what fishing is like, and the fishermen going out and getting the fish. But, it's good they get fish, I suppose, to feed people. But, yeah, they're catching dolphins and porpoises like pretty much every time they go out. So on a long fishing trip. So I just wanted to throw that out there. Anyone know why the right whale is called the right whale? No? Anyone? Guy in the green? No? No? It's because it's the right whale to catch. The North American right whale, which is one of the most endangered whales in the world at the moment. And I guess none of you know why it's endangered. One of the reasons it's endangered now. Because obviously we're not catching whales in the Atlantic anymore. So the thing that's damaging them is long lines. So you get like a long line, like a lobster pot or something. So you've got a pot on the bottom and a buoy at the top, and the whales can't see them because their eyes don't work like ours. It's like a line in the water, and they just swim right into them, and it just slices them up. And then they don't die straight away. I'm not going to go into it anymore. But yeah, you get the idea, right? That's the right whale. That's why the right whale is still endangered, even though we're not catching them anymore. So yeah. It's just a food for thought there. So I'd just like to thank my sponsors. I don't really have sponsors. But yeah, Bluefruit Software. It's a company I'm mostly working for now. They do a lot of good work too. It's medical mainly now. And I'd like to thank Chelonia, who are the people making these amazing devices. And it is properly heroic work, basically. The guy that runs it is an ex-GP. He was GP for 35 years, retired, and started this bloody company, which takes some balls. Taught himself how to program for the higher level part of it that sits on the desktop computer. Amazing. and then selling them all over the world now because people haven't solved this problem yet. And I'd like to thank the Agile Alliance as well for loads of amazing ideas about Agile, and they're not a sponsor of my talk either. None of these people are sponsors of my talk. Any questions? No? You're all really, yeah, go on.
Well, I mean, it's not about it's about the dolphins.
Oh, yeah, go on. That's good.
First was, if sound and bubbles sound like dolphins, then you've got maybe more problems than just...
Yeah. That's right. So I'd just like to explain again that there's a two-part process to this with our particular dolphin detectors. You have something that sits in the water with an FPGA on it, and the FPGA is doing the preliminary filtering of the noise that it hears, and it can't filter out the sand noise, the sediment transport noise. And then we bring the data back to base, and when you've got it back in base, you can use a full-blown desktop machine and lots of very interesting techniques that look for particular identifiers in the sounds, and you can tell what is sound noise and what isn't. But yeah, that's a good point.
The actual question is, if nobody can tell how many dolphins there are, what people do with the data?
Yeah, so again, as I mentioned, although you can't tell the exact population, you can tell whether it's increasing or decreasing. So as long as your systems are consistent. So if you're using the same dolphin detectors, running the same hardware, you put them out again, and if you get more data next time, at the same time of year, you do have to match it with the times of year, because dolphins, they swim all over the place. And if you know this, the dolphins in Cornwall at the moment that have swum down from up in Scotland, and they're just having fun, dolphins. They've really nailed life. So yeah, they do tend to swim around at different times of the year, but you can tell over time whether the trending is trending down or trending up, and that's what they care about, conservationists. They don't care about anything else, really. So even though they don't know exactly how many, well, they'd love to know exactly how many individuals there are, but we're actually still trying to solve that problem for them. There's a statistician working for Chelonia now, who's an AI-obsessed statistician using R and trying to solve that problem. But he's probably not going to solve it. He's just going to make some progress towards solving it, and someone else will hopefully solve it. What was your question?
I was just going to say that I know they're obsessed statisticians
Yeah.
on dolphins.
Oh.
I'm wondering if you've got the same guy.
It could be this Eric's his name.
And this one's called Kim.
Oh, right. We should talk. Yeah, you should give me his details. Yeah. It'd be good to put him in touch with Eric.
Yeah.
I'm sure they'd have a great conversation. Yeah, cool. Any other questions? No, I'm sorry there was some embedded stuff in there too. Hey.
You mentioned you do it roughly about 3 updates a month. So what do those sort of updates consist of? Just bug fixes?
No, not just bug fixes. Sometimes it does vary a lot. Sometimes it's a feature. So people think of a new way of filtering the data, and they want to apply settings that let you filter it, like with slightly different settings, and that was quite a big chunk of work. I switched out the file system for a different file system about 6 months ago or something, because we had repeated problems where the file system seemed to be just falling apart on us, and I looked at the code and it was just terrible. So I updated it to Chan's file system, ChanFF, which I'm sure some of you have heard of, and it's not brilliant, but I didn't have time to write a whole file system, so and I probably wouldn't make something that brilliant to start off with anyway. It would take ages to refine it, so I swapped out the file system, and yeah, it's things like that usually, and some modifications, like for log files. That was quite a recent change, and added the data file. Simple, but yeah, there's not much to do really. It's mostly just, looking into reports and, maybe sometimes changing things a little bit to make them a little bit safer. I have changed the way the watchdog works a little bit recently. But yeah, it's minimal things really. No other questions? Cool, thanks very much, that was awesome.